working in MENA region on open banking. So I am over here basically heading the DevOps team, and basically we are setting up the complete infrastructure and all of that. So it's a startup and we are growing rapidly. So I'm basically the DevOps guy over there.
Okay, cool, good stuff. And how long have you been working there for? I think you said that already.
I switched recently. I switched basically on in January.
Okay.
Before that, I was working in Stakater. I was working as a lead over there. So I switched in January to Tarabut Gateway. Yeah,
All right, good stuff. Um, very, very good. And you studied, I imagine, computer science, or
yeah.
yeah,
I've studied computer science in my bachelor's.
yeah, yeah. But also as well, you worked as a trainer. I mean, we can talk about this later, but you also do some training stuff. Maybe it would be good as well too. We can share some of those links later on, so if folks want to check that out. Do you do? Okay, very, very good. We already got some folks in here. All right. And there we go. Hello, Leonard. All right. Very good. It's very, very nice. Ever since we did KubeCon, we've been getting a lot more interaction with lots of people, so it's good. But yeah, so on the training side, when did
Yeah.
you start working as a trainer?
It's been almost, I think, so 2 years now. I started in June 2019. Basically, what we do is we have sessions of DevOps that
Yeah.
covers Kubernetes, Docker containers, Git, Ansible, and all of those tools. So we have a 8 week session, and we cover that over there. So basically, that is what I do part time on Saturdays. So whenever an iteration starts, so I do training on over there, basically on DevOps.
Okay. And when do you have free time? You say you
Yeah.
work on Saturdays.
Yeah, basically no, that is I have gaps in between the iterations. So basically one iteration of 8 weeks goes, then I take a gap of 2 months almost, and then I start another iteration. So yeah, other than that, obviously life is a bit busier nowadays, but I really want to grasp all the opportunity which is at the moment.
It's a good point. It's a good point. And the thing is, like, imagining 2 years ago, us having this conversation right now, it could have happened, but it just wouldn't have been probably as frequent or as possible. And that's one of the cool things about our community is that being able to interact with, I don't know how many countries I'm interacting with every day, but I love it because it's like I feel like I get to travel. That being said, I think we can kind of start off in a more formal way. Welcome everyone to meetup number 49 in English. We've had other meetups in other languages. It would be very interesting to do a meetup in Urdu at some point. I practiced a little bit of Urdu, and you can help me, Ali, to make sure that it's correct. To say welcome, I believe it's Khush Amadid.
Kushamdit, yeah.
All right, good. With my wonderful American pronunciation, I know that. I know shukriya, which is thank you.
Yeah, shukriya, thank
And then if we switch into Arabic, I did learn Arabic 11 years ago in Egypt and later in Palestine. But anyway, that's not the objective of today's meeting. But like I said, we're always in the Data on Kubernetes community looking for as much diversity as possible, folks from different countries, different backgrounds, different languages. We've had meetups in Hindi, we've had meetups in Spanish and Portuguese, have a meetup in Russian on the radar. Ali, we probably need to plan a meetup in Urdu. Speaking of which, our guest today is Ali Kahoot, who's an amazing engineer, very, very active. We're just talking about the free time that he has and doesn't have. Ali, can you just tell us a little bit about yourself before we get started?
Sure, I will tell myself. Basically, my name is Ali Kahoot. I'm a DevOps engineer and a DevOps trainer, part-time DevOps trainer. It has been almost 6 years that I have been working in this field. I previously worked in Stakater as a DevOps lead. I have basically set up the complete team over there, and we basically used to provide a Kubernetes offerings over there. I am a computer scientist by background, so what I believe that helps me is because I know what issues a developer would face, a normal developer would face. So that's why what I believe that I can help developers basically reach over here, and they can work on or learn the DevOps tools and technologies that how what issues they would face. So I can work on that. Other than that, I am currently working as a DevOps engineer at Tarabut Gateway. It's a Bahrainian startup, so which is working on open banking in the MENA region. So I am currently the DevOps guy over there. We have set up the complete infrastructure on Kubernetes, and all the pipelines and all of that are on GitHub Actions. So yeah, that's some of it.
That's a good summary. Yeah. And with that in mind too, it's interesting to see regarding sectors, because when we get, we've, like I said, this is meetup number 49. We'll be having meetup number 50 this week. We've seen lots of different perspectives, but I would say the financial sector does seem to be one of the strongest examples, along with telecommunications, along with healthcare. What is it about that sector that you think makes it a good candidate, a good use case for technology such as Kubernetes?
One of the most important thing would be the security, because in the financial sector you need security, because we have quite sensitive data and which we need to basically be secured. One thing is that. Other thing, obviously, microservices based architecture, we are working on different sort of applications, the small applications which microservices based on the microservices principle. So we all have sort of covered all of those principles, and we are trying to move towards the cloud native sort of applications. So Kubernetes sort of covers each and everything. We had moved to containers previously as well, and I have worked on Kubernetes previously as well on containers, but obviously managing containers is quite hard. Simply managing containers is quite hard. So you need a container orchestrator like Kubernetes or any other such OpenShift, some of those tools basically to help you manage to offload things on from the DevOps engineer. So you need automation to offload things. You should not be asking your DevOps engineers each and everything or pinging him for each and everything. Kubernetes handles most of those things itself. So
I think it's a really good point, and I'm really glad you mentioned that as well too, because we're interacting now more and more with younger folks, and I think a lot of times, whether it's younger or older, but people that are new to this world, a lot of times it seems really, really overwhelming. And like you said, it's a lot of a question of focus. It's like, don't worry, your job, we're gonna be adding some things here. There are gonna be some modifications, but you don't need to be jumping into absolutely everything. I know there's a lot of excitement, and when you look at all the memes and the Kubernetes ecosystem, a lot of times for folks, it gets really like, whoa, how can I possibly learn this? But I think the question is, maybe you don't have to learn exactly all of that, right?
yeah.
And taking it a little bit further, because obviously, our community is focused on data on Kubernetes. Today, we're going to be talking about stateful sets, deployments, Daemonsets. When was your first experience? What did you first encounter? Because you've been working on this for a while. I'll later link the blog post that you put out a couple of years ago, which lays this out very clearly. But when the data question came up for the first time, what did you think about it? How did it seem? Did it sound like a crazy idea? Stateful, stateless? What did you think?
Basically, we had an application that we had to convert to microservices, and we had to basically break the database of it as well, considering the principles of microservices. So we did that, but at that point, we also were looking to deploy databases. So what we did was we looked at the Helm charts and we deployed those Helm charts. But one thing that I was confused at, why aren't they using deployments for data? We are using deployments for our application, but why not the Helm chart when I'm deploying a Helm chart for deploying, for example, Postgres or MySQL or anything of that database, they are using stateful set. So that was one question, that why do we need a stateful set? That why is stateful set another resource provided by Kubernetes? Not how can we just use deployments or those things? So that was one thing that grasped my attention, that all the Helm charts they use stateful sets, because previously I didn't know about it. But obviously the first thing that every developer does is he should deploy the Helm chart of a database whenever he wants, and all the Helm charts they deploy stateful sets. So that was one major I would say breakthrough in my career, that I started reading about what are stateful sets and why do we need stateful sets and not the deployments or simple pods. Why can't they work as efficient as stateful sets? So then I started to research on it, and then I found that there was no specific blog that caters to all of this. So then when I started reaching out, listening to different videos, creating an application myself that I deployed using 3 different models. So then I started to understand the differences, and then I thought that it is the best opportunity to write a blog on it, because there is none at the moment. So yeah, that's how that blog came into the picture.
And once again, like I said, that was around 2 years ago. So we can say you're sort of an early adopter into this space, because, like I said, we've interacted with lots of different folks. Our community's been around for about a year now, and like I said, is that one of the challenging things and one of the reasons why our community exists is exactly the reason that you mentioned, is so that there is a space where those resources can be shared, so that it's not so overwhelming. You obviously entered those questions with a fair amount of background, experience, things like that, the capacity to build your own application, start working with it directly. But for example, we got a question right here already from Leonard, and he's asking, as a Kubernetes newbie, I know about persistent volume claims, but the thought of pairing an SQL or Postgres database to a cluster is daunting. Like we were saying the word overwhelming earlier. Could you describe quickly how we actually pair databases in a Kubernetes deployment? Or perhaps you're going to get to this later in your presentation. Or anyway, if you can answer now, what do you think?
Yeah, I would get that in my presentation. So I would think that
okay, Leonard, hold on to that question. Let's jump into the presentation right now. I think it's a perfect segue. And Leonard, if for whatever reason we don't get to that question, please remind us, and we'll definitely get to it later. So Ali, if you want to share your screen, go for it.
Yeah, okay. I'm sharing my screen. Let me know if you can see it.
Okay, good. And just as a reminder, feel free to ask questions here in the Zoom, or if you're joining us on YouTube or Slack, whatever, get those questions out there. And I already told Ali, if we're not able to get to everything during the meetup in this 1 hour, we can definitely continue the conversation later in Slack. Go
Yeah,
for it.
sure. Okay. Okay. So welcome everyone to the 46th meetup. My name is Ali Kahoot. I'm a DevOps engineer at Tarabut Gateway. I have covered most of it already. I'm certified in data delivery specialist. I will not be covering most of it again because I have covered it. Okay. So let's jump on towards containers, because moving towards Kubernetes, we need to know what a container is and how does a container help, and what does the Kubernetes do to a container. So what is a container? I will be going through word by word. So previously what happened was, if you wanted to ship a car to another country, or if you wanted to ship a barrel to another country, or for that matter any box or anything, you had to have different sort of shipping methodologies. But once the containers were basically introduced, so what you had to do, you had to ship your car into a container, you had to basically move your oil barrel to a container, a box to a container, and you had to make a ship or anything that would just transport that container. So you would not be worrying what's inside that container, whether it's a car or anything of that sort. Similarly, when the Docker containers, they were introduced, so you had to just basically modify your application so that it runs on containers, whether it's a backend application, a front end application, a queue, a database, or anything. You just have to run that on a container, and on your infrastructure you have to install any sort of a container runtime instance, for example Docker, that would be running those containers. So whether it's a backend app or database or anything, you just have to make an image out of it, Docker image out of it, and run that container and make your infrastructure capable of running those containers only. So this is the diagram of a basic container architecture. You must have seen it a lot of times. Whenever you search for containers on Google, you would be getting this. For example, there is a base infrastructure, the hardware, then there is a host OS, and then there is a container runtime, for example, Docker or CRIO or anything for that sort. And then in your image, in your Docker image, or in basically you install the libraries, the binaries, and then your application code on top of it, and you run those containers on top of using the container runtime on top of the host operating systems. So basically, this is sort of how a container works. But for example, how can you pass an environment variable to a container? I have an application, for example, a Java application. How would I be passing environment variables, having volumes over it? How can I persist data on a container? So all of these resources are provided by Docker or whatever the container runtime we choose. They are provided by those. For example, Docker provides us with an opportunity to add environment variable to our applications, mount any volume, mount any data path to a persistent volume. So that's how we can persist data for an application. We have networking, how two containers would be communicating with each other, with the command, which command you want to run whenever your container would be running, health check, and resources. So these are all the resources that are provided by Docker or container itself. And these are some basic commands for it. For example, you add an health check for your application in your Docker file, and then you run your application by using this command, docker run -it -e name. So I am passing an environment variable of name Ali Kahoot to my container. The network is DoK, the volume I am mounting of this path, and specifically I'm basically providing the resources for it to be used, 1 GB of memory only, the image I am using, and the command. So all of these resources are being covered by this one command. So now if you have to manage the Docker itself, that is a headache in itself. So basically, if you are managing containers yourself and individually, that is quite a headache. You cannot do that individually. You would face a lot of issues if you, and especially if you are in production or any of that sort of environment, there would be quite downtimes, and everyone would be pulling your neck that why was it down or anything for that sort. So for that matter, Google introduced Kubernetes. I would not be jumping into the details of what Kubernetes is, just a brief example or a brief definition of what Kubernetes is. It is a container orchestrator, which means that it manages containers. Previously, if a container went down, there was no one that would be working on it or basically pull that up. So what container does is it orchestrates that. It manages your containers. Whenever a container goes down, it will be keep looking into it, and then it will try to bring it back up. Whenever there is a load, you can scale it. The networking is quite easy in Kubernetes. The clustering part, for example, previously you had just one machine which has, for example, 8 GB of memory and 2 CPUs. So you cannot run containers more than that. What Kubernetes does is it provides a clustering sort of an architecture. You can cluster different nodes onto it. So that's some of the benefits of Kubernetes. So coming to pod, what is a pod? A pod is the smallest deployable unit in Kubernetes. You cannot deploy a container on Kubernetes. Rather, you would be deploying a pod, which in itself will be deploying containers. So a pod is just a wrapper around containers. It is the way to ship containers or to run containers in Kubernetes. Kubernetes way of provisioning containers. And this is a descriptive way. You can write a YAML for it, or in JSON you can declare your containers and you can run those containers. So a one pod can have one or more containers as well. So but in an ideal scenario, you would never be running more than one application per container, per pod, sorry. So you can have a sidecar container in your pod, but not two applications running in a single pod. For example, you would never be running a front end and a back end application in a single pod. But what you can do is you would be running a database and a sidecar container, which will be taking backups of your database. So that is a sidecar helping container, not the main application. So the ideal rule is you would never be running more than one application per pod. You can have more than one containers, but they would be helping or sidecar containers. And this is the whole architecture of a container in a pod. For example, this is a worker node of your Kubernetes cluster. Kubernetes provides you different architectures. One is the master node and other worker nodes. So whether it's a worker node or a master node, the infrastructure remains the same. There is the hardware, the host operating system, the container runtime, Docker, and another tool named kubelet. So now in Kubernetes, what will happen is you will never be running commands like Docker run. Those commands will be managed by kubelet. You will be creating a pod, and API server will be scheduling those pod using the kubelet, will be communicating to the kubelet that I have received this specifications of a container or a pod, and then kubelet will be running those pods and containers on specific worker nodes, whichever are free based on the resources. And similarly, the same structure, the application, the libraries, the binaries, the image is again made by you. Kubernetes does not do that. You have to build that image. Then you can pass on the environment variables, the volumes, the networks, the commands, and all of those to your containers using the pod definitions. So that is how a Kubernetes pods work, and how you can pass on different information to your containers using the pod definition. So this is a simple example. For example, this was the same command that we ran earlier using the Docker command, and now the same application, it is run using a Kubernetes pod definition. So for example, I have created a pod with name this, container this. This is an array. As you can see, I am mounting a volume over it. That volume is coming from a PVC, and I am mounting on this path. So these are this is how you define a pod. Now, coming to controllers, what is a controller concept in Kubernetes, and how do controllers work? Because whole of the Kubernetes, the infrastructure, the architecture is based on controllers. If we don't know what controller is, then obviously it would be quite difficult to understand the whole Kubernetes architecture. In a simple way, if I explain, the controllers are just a security guard or just a watchman that would be of continuously trying to sync the current state and the desired state. So whenever the current state is not equal to the desired state, it will become unhappy and it will ask the Kubernetes API server to do something to fix this. That do something would obviously be to sync the current state into the desired state. So this is the basis of Kubernetes itself, the controller architecture. There are a lot of controllers that I would be mentioning later on as well, but this is the base of it. And whenever the current state gets equal to the desired state, the controller gets happy, and it again starts sitting in a loop that whenever the current state goes out of sync with the desired state, it will again ask the Kubernetes API server to try to fix it. So there are different controllers in Kubernetes: node controllers, service controllers, ingress controllers. You have to deploy yourself. Then there come these different controllers that you can deploy for deploying your application, the replica set deployment. Replication controllers have been depreciated, so you don't need for that. But replica set deployments, stateful sets, and Daemonsets, you can use these to deploy your application.
Really quickly, Ali, we got a question on YouTube. Someone asked, why can we not set multiple replica sets on an EKS cluster?
We can set up multiple replica sets on an EKS cluster. Replica sets has nothing to do with an EKS or anything. It is the base of Kubernetes, and you can create multiple replica sets. We will be creating replica sets. Replica sets is quite straightforward, which we will be covering next. And we can create multiple replica sets. There is no compulsion on that.
Okay. I guess the question is, there's going to be a lot of stuff covered in this session. Let's keep going.
Okay. So again, as we said, replica set. So the issue with pods, for example, if I simply deploy my application using pods, using individual pods, the issue is that these pods cannot be updated. For example, I have a new version of my image. It cannot be updated or it cannot be scaled. I cannot scale my pod. For example, if I have load on my application, I cannot scale my pod if I have individual pods. Obviously, and if the pod is deleted, they cannot be recreated. It will never be recreated on its own. What replica set does is it manages the pods and its replicas. For example, I want to have 3 replicas of my application. So what I will be doing is I will be specifying 3 replicas in my replica set definition. And what it will do is it will create the exact same copy of those pods that I mentioned. It will be creating the exact same copies of my application. The replica sets, what it simply does it just creates replicas of your pods. The replicas are exact same copies. The pods of a replica set can be used interchangeably. So as I said, that they are exactly similar to each other. And so replica set is a controller that what it will be doing is it will basically see that the desired replicas of a pod are 3, current replicas are 0. So it will ask the API server to increase replicas. And when the current will be 1, again 1 is not equal to 3, it will again ask the API server to increase a replica. Again it will be 2, and once it is 3, now it will become happy. So now what if I go and I delete a pod manually? If I delete a pod manually, again the current state is again 2, the desired state is 3. So what the replica set controller will do, it will again ask the API server to create a new pod with all of these specifications, and API server will then create that pod on any of the nodes. So this is a basic replica set controller that what it does is it just creates replicas of your application. And once the current and the desired states are equal, then obviously a replica set controller gets happy, and it's then again starts to look into the loop. So what are the shortcomings of replica set? Why don't we use replica sets? You must have listened about deployment, stateful sets, Daemon sets, but never replica set as an option to deploy your applications on a production setup. So why don't we use...
Quick question. We got a question from Leonard. Thank you, Leonard. Is a replica set the controller that controls horizontal pod autoscaling?
Yes, basically horizontal, the pods are basically, if you use an horizontal pod autoscaler, what that will do is it will create a new basically it will increase the replicas for your replica set. So in replica set definition, what we do is we mention the replicas we want for our replica set. So what that horizontal pod autoscaler will do is it will update the replica set to be using or basically updating the replicas for that specific replica set.
Thank you.
So what are the shortcomings for replica set? Replica set does not handle versioning. The issues for public pods that we mentioned earlier were, one, that versioning is not handled, and one other was that the scaling was not handled. But replica set handles only the scaling part of it, but versioning is not handled. For example, my application is running on version v1.0 and I want to update my application to v2.0. Replica set doesn't do that. You would have to delete the previous pods, and only then the new pods will be created with the newer version. So I have a demo for it. I will just be basically I would try to cover all of the topics that I am doing in a hands-on exercise as well. So this is an EKS cluster. I have created a cluster with my name Kahoot. It has a 3-node cluster, so 3 nodes are running. Currently, there are only 3 volumes, each for 1 node. And this is the counter application that I have created. for it. So basically what I will be doing is, if I show you the simple pod, this was the simple pod that I mentioned earlier. So that I can, if I create it, the simple pod, and if this is the cluster, this is the lens Kubernetes IDE, and this pod is now created. And if I check the logs of it, it says the attendees are awesome. So all of you are awesome. You can be happy, and Kubernetes certifies that you are awesome. So, but the issues that we mentioned about pod. So what if I delete it manually or by mistake or anything? It will not get recreated, or it is terminating. So it's not that it's recreated, so it is terminating. So now if I create a replica set, this is an RS replica set, and I have two replicas, specify two replicas for my application. And if I run this, we can see it is still in terminating state. I don't know why it should be terminated till now, but yeah, this is the replica set. So you can see that what I created, it was a replica set with name DoK-RS, but the pod was created with DoK-RS- a unique ID. So whenever replica set creates a pod, it uses a random ID for it, and it creates that. So if I see again, it is again logging the attendees are awesome after every 10 seconds, because that is what I have asked it to do. After every 10 seconds, it will log the attendees are awesome. So it is a replica set. But for example, I want to update my image to this. Previously, I was using BusyBox latest, but now I want to update my image to 1.33.1. And I apply the application, it will say me that the replica set has been configured. And if we see over here, the replica set is configured, but the pods do not take that change, or basically that change is not reflected onto the pods. So if we see the image over here, where is it? Yeah. So still the image is BusyBox. The pods have not been updated. So replica set does not update the versioning of the pods. But what if I delete the pod manually? Then the new pod will have that new image. But obviously we don't want such type of sort of a behavior that we have to manually delete every time. So over here you can see the new pod has the newer image, but the previous pod, it still has the old image, the BusyBox. So that is how why we cannot use replica set for deploying our application. So if I go back again, and we basically talk about deployments. So what deployment does is it handles the replica sets based on the update of configuration. So for example, I apply a configuration. What deployment will do is it will create a hash out of it, and it will create a replica set for it. And when I update that configuration, for example, in the previous example, I updated the image for it. And when I update the image, it will create a new replica set. It will provide a rolling update, and it will provide a new replica set. And what if that new replica set or that new image has some error or bug in it? So what it will do is it also provides the support of rollback. How it does that? For example, deployment is also again a controller.
Sorry, really quick question as well from Sardi. Sardi, always asking good questions. Thank you very much. Question is it possible to have multiple replicas, but each replica container having access to an environment variable that would reflect a replica's ID and having this value accessible from within the application code?
Basically, we can do that. We can use Kubernetes API for that matter. For example, if we use that natively, I am not sure about that, whether we can do it or not, but I don't think so that we can do it, because we can get the data from the metadata, but I'm not sure about it. But obviously, we can do that if we write a Kubernetes API inside of it. So whatever language application you are writing, you use the Kubernetes SDK, and you implement the methodology of getting the replica set ID of this pod. You can do that based on the code. So you have to implement that yourself. If you can get that natively from Kubernetes, I'm not sure about that, but I don't think so that you can only get the pod name. So those things you can get. I'm not sure about the replica set ID. Okay, so moving forward, so now I'm deploying a deployment, for example. So my desired state is, in the previous example, DoK app with BusyBox 1.33.1 image, and the current state is that the BusyBox latest image is deployed. So what the deployment controller will do now, it will create a new, it will ask the API server to create a new replica set with busybox this image and downscale the previous replica set as the new replica set is getting up. So basically, and once that is up, it will be green. So let's show the exact example. I will just delete the replica set that was created earlier. And now if I deploy the deployment, so now we can see its name is DoK-deploy, and the pod name is, if you see, DoK-deploy, a unique ID dash a unique ID. So why are these two unique IDs, and how come these are two different IDs? So deployment, what it did was it created a replica set, the 6D294 basically. I created this deployment, DoK-deploy. It created a replica set, DoK-deploy-6D. And this replica set then in turn created these two pods, whose name are basically 699, the name of the replica set, dash a unique ID for the pod. And now if I update my deployment with 1.33.1 image, so what will happen is it will create a new replica set. So you can see over here a new replica set is created, which is being scaled up, and the previous one is being scaled down. So that's how the versioning is handled. And for example, there is an error in the new deployment or in the new replica set. What I can do is I can simply scale this one back down, and I can scale this one back up. There is a command from kubectl as well, kubectl rollback. So what you can do is you can roll back to the previous version if there is an error in your new version of your application. So that is why deployments are the default method of deploying your applications in a production setup, or even whenever you want your application lifetime, because they provide you the versioning of your applications. If the newer version is gets an error, you can easily still roll back. And also that you saw that it basically did a rolling update. It scaled this one up and it scaled this one down. So for example, if this one got an error in between, or for example, if I had mentioned a wrong image name, for example, if I go over here and I mention a wrong image name, this is a wrong image name. Obviously, this image would not be existing in Docker Hub, and I apply it. What it will do is it will create a new replica set, but that replica set will never get, the current will never get one, because it will be stuck in image pullback, and your application is still up due to the previous replica set that was created. So that's one of the most important benefit of deployment, is that it provides rolling update. So these are your two applications that are still up, even though you have mentioned the wrong image name. You have basically committed a blunder at your end, but Kubernetes, as it's a fault tolerant system, so it is sort of tolerating that fault when you are using a controller for controller deployment. So I will just again delete it, and now going back to the basically slides. Now another controller is Daemonsets. Daemon set is almost similar to replica set. That's exactly the same to replica set. The only thing different from a replica set is that each replica of a daemon set, it will run on each node of your cluster. So for example, you have 5 nodes. There will be 5 replicas of your application, and each one of them will be running on each of the nodes. So that's how daemon sets work. They also provide rolling update, but they cannot do rollback, because as we mentioned, that replica set does not have rollback option. Deployments have rollback option, but daemon set is similar to replica set. You would be basically thinking that why should we deploy a daemon set? Why would we be needing replicas equal to the number of the nodes? So for example, I want to monitor my cluster. I want to monitor each node. For example, my node 1 is consuming 100% of or 80% of the memory, node 2 is consuming 60% of memory, node 3 is consuming 70% of the memory. So I should be able to basically know how much memory and how much all of those things are being consumed. So what I will be doing, I will be deploying a daemon set of my monitoring exporter. So they will run on each node, and they will be sending the data about your application or about your nodes to Kubernetes, that this node is this node is this. So in that cases, obviously you need a daemon set which will be running on all the nodes. Similarly,
Sorry,
if you
quick question. What are some applications? Once again from Leonard. Thank you, Leonard. Actually, two questions. What are some examples of applications that we will run as Daemonsets? Fluentd, anything else? And what are some of the more interesting apps you've run as Daemonsets?
Sure. Okay. So basically, as I mentioned, Fluentd, this is the logging exporter that you just mentioned. Fluentd, what it will do is it will basically scrape all the logs from all of your nodes. Basically, it needs to run on all nodes. It will be scraping the logs and it will be pushing the logs to Elasticsearch or any other storage that you are using. And the other thing, as I mentioned, the monitoring exporters. What you also need the basically metrics of your nodes. So you would be needing daemon set and that as well. As similarly, another daemon set that comes by default, that is a kube proxy. For example, if we go over here and I choose all namespaces, so you can see kube proxy is another daemon set that is running. Kube proxy is a tool that handles the networking of your cluster. So it should be running on all the nodes as it needs to manage the networking, that which pods are running on this node, and it manages all the basically the routing table of your Kubernetes cluster. So kube proxy is another thing. The AWS node. So I am not sure what this does is, but obviously this seems so that AWS runs this on its EKS cluster to monitor anything or to do anything for that sort. So anything that needs to run on all nodes, gather information or do anything, do any update on your nodes. For one other example that I used on my production cluster as once was, if you remember that Docker, they basically Docker Hub, they implemented the API limiting on their basically infrastructure. So at that time we had a production downfall because at once the API limit started reaching and the images were unable to download because the API limit reached. So what I did was I created a daemon set that would update the Docker config of your nodes, and it will basically provide my credentials over there so that the API rate limiting does not hit. And we had a paid account, but we were not using it because we didn't think of that API rate limiting would ever cause any issues for us. But what we did was we created a daemon set that updated the Docker's configuration for each of our nodes, and at once we rolled that to production because for some time, for a brief amount of time, we were affected because of that. So that is another example of a daemon set. Okay. So again, daemon set is a controller, but what it will do is it will make sure that each replica is running on each node of your Kubernetes cluster. So 5 node cluster, 5 replicas, 3 node cluster, 3 replicas. And once all of them are up, it will be happy. And that. Stateful sets, they are only used for apps with persistence, so I'm not mentioning them over here. I have a complete section for persistence, which I will be covering. So just an example of daemon set, if I run the same example as a daemon set, if I go over here and I just choose the default name, so this is the DoK DS, the daemon set. And you can see that each of them is running on a different node. This one is running on 2083, this one is running on 2252, this one is running on 2122. So all of these are running on different nodes. And I have a 3 node cluster, so 3 replicas, and each one of them running on each node. So that is another example of daemon set, how it works. It does the same thing because I have used the same application. That just prints the attendees are awesome. So moving forward, if I go present. So now coming to persistence in Kubernetes, how persistence is handled. This was just a brief difference between deployments, replica sets, and daemon sets. Now coming to persistence in Kubernetes, how does that happen? So for this section, I will be using a sample application, a counter application. What it does is that it reads from a file, the last line, increments the number, and writes back to the file, and sleeps for a random time for 1 to 3 seconds, and then again does the buff step. This is the script that I have written, and this is available over on this URL. I have open sourced it. So what it does is simply it reads the file, the counter.txt, it increments it, and it basically increments it, and then again writes back to the same file, and then sleeps for a random of about 1 to 3 seconds. and it just sleeps that, and basically it continuously does that. So oh, basically over here, sorry. So what happens when we talk about persistence in Kubernetes? As I mentioned, that volumes and all of those things are part of containers already. You do not need to do anything for that sort. But what Kubernetes does is,
sorry, one quick question.
Mhm.
Daemonsets support replica sets. Can I run two Daemonsets on the same node?
No, Daemonsets don't support replica sets. They run only on different nodes. You cannot run a daemon set on two replicas of a daemon set on a single node. You cannot do that.
Okay, perfect. Thank you.
So basically what happens is, for example, you have a container and you want to mount the /app/data path on a volume. You want to persist this. So for example, MySQL has a path of /MySQL/data or anything or any databases. So I want to persist this data. So what I will be doing is I will create a PVC. I will show you the definition of a PVC. I will create a PVC. I will use that PVC as a volume in my pod. So for example, I created a container 1-PVC. I use that as a volume in my pod. And then I am mounting this volume on this path on my container 1. So for example, I have 3 containers. I can mount the same volume on those 3 containers. But as I mentioned, that it's not a good policy. It's not a good practice to have multiple containers running in a single pod. So we should avoid that. So, but coming to persistence, what will happen is I will create a PVC. It will create a persistent volume, which will create an actual physical storage on the cloud or wherever your cluster is hosted. It will actually create that, a block storage or a file storage, whatever you use. And you will be basically creating a volume which will use that block storage, and you will mount this data on that storage. So whenever I write anything on this path /app/data, for example, I create a file named alikahoot.txt, it will be stored on this physical storage. So if I show you the example over here, this is the persistence. This is a persistent volume claim, and let me apply this as well. And here I'm using this PVC DoK over here in my volume. I have mentioned the persistent volume claim name to be DoK. I am using 1 GB of the storage, and this is mounted on data on Kubernetes path. So now if we see over here, this is my pod. It is still waiting for the persistent volume claim to be created. If I go to storage, PVC, this is created. This is just created 21 seconds ago, and this is the PV that is created in response of it, DOK. And if I go to my actual cloud, as I showed you that previously there were only 3 volumes. But now if I refresh it, so now I have a new volume that has been created. If I check the tags, so basically this is the PVC name. This is the PVC name. This is the DOK, that PVC name that I created, and this is the namespace default. So this is how the actual persistence is happening. So for example, just ls, if I go to data, sorry, not ls, cd data on Kubernetes, if I create a file a.txt. So if you can see, I have created a file a.txt. I exit from it. I delete my pod. The pod is deleted, and I create another pod, persistence pod 2. But the volume and the PVC are still the same. So you can see over here, it is successfully assigned, pulling image, successfully pulled image. I think so it is taking some time to terminate, because once this will terminate, only then this will start. Okay, so this is started. If I go to cd data on Kubernetes and I do ls, I can see that same file that I created on the previous pod. It's still there. The data is persisted.
Quick question from Michael. Thank you, Michael, for the question. Can you show the YAML for persistent volume?
Yeah, basically this is the persistent. Okay, we are creating persistent volume claim, which in turn creates the persistent volume. So this is the persistence volume. If I edit it over here. So this is the actual spec of it, the capacity with that we said that AWS block store, the access mode, the claim reference, the storage class name, because I didn't mention the storage class name over here. So it picked the default storage class name on AWS. The default storage class name is GP2. So it created this. This is the PV, the persistent volume spec, all of it. So you can create PV yourself as well, but that would be a manual step. Over here, what we are using is we are using claims. So I created a claim, which in turn automatically created a PV persistent volume for me. Okay, so I will be deleting this and now moving.
Follow-up question from Michael is, okay, so it's created dynamically with the help of storage class.
Yeah, it's created dynamically with the help of the storage class. Whichever storage class you use, it will create and provision that block storage for you, whichever storage class that you have used already. So persistence in deployments, how does the above persistence, which we checked on a single pod, how does that work for deployments? Because deployments create replica set, then comes the pod. So how does that have worked? So over here, for example, I have a deployment named counter, which has one replica. It will create replica set, which will create a pod, and I have a PVC counter that I've already created and mounted on my deployment. It is the same as it was in pods. But what if I scale up my deployment? I scale up my deployment to have 3 replicas now. So how will that work? I have a deployment with 3 replicas. It created a replica set. Each of the replica set now created 3 replicas, and each of them is sharing the same PVC, the same volume. Each of them are sharing the same volume. So this is how persistence is happening in deployment, because deployments are not meant for stateful applications. In deployments, what they do is they all share the same volume, because as I said that pod XYZ1, pod 1, 2, this, all of these 3 pods are interchangeable. They should be interchangeable. One can replace another. So that's why there is no specific order for the pods. They can be interchangeable. So all of them share the same volume. Same is the case in Daemonsets. The only difference is that the Daemonsets, the replicas would be running on different nodes, all the different, but they would be sharing the same PVC. For example, I showed you the application, the counter application that reads from a file, increments the variable, and then writes to the file again, and then sleeps for a random 1, 2, 3 seconds. So if I go to and deploy a deployment over here, this is my deployment counter. This is my image that I have created with this specific shell script that I mentioned, and this is also, only difference is that now I am using an EFS storage class, because EBS, the block storage, if you know a bit about block storage cannot be attached to more than one instance at a time. Block storage can only be attached to only one replica. Other replicas will start failing and say that the block storage cannot be attached to more than the file storage means that you can attach it to multiple instances at one time. So we are using elastic file system of AWS for this example. Now if I deploy the deployment, and we see over here, now my deployment is created. It has only one replica at the moment. The PVC is created. Counter, the storage class is EFS. Now if you see, this is my replica, and this is just again logging. Basically it started from 1, 2, 3, 4. It will read the the file, increment it, and log it back again. So it is all in a sequential form. But what if I update the replica?
Sorry. One more question. In practice, do pods that are deployed with PVC take longer to spin up? And how reliable are PVCs in helping pods to persist state? Did you notice any latencies?
No. Basically, what happens is that an EBS or whatever cloud you are using, that get attached to your node. So, for example, when I showed you volumes over here, so these 3 nodes are also attached, and this is one another volume that is attached to your node now. So there is no latency on it. The default way of persisting data is using PVCs and using these. Obviously, if you have quite sensitive data, you can use a better storage class or a better volume claim. For this, the IOPS is 100. You can choose a better storage class which has a better IOPS, but obviously that would be expensive. So pros and cons are on both the sides.
Regarding that as well, in terms of your experience with some of the different solution options that are out there, when we say, Ceph, Rook, OpenEBS, which one have you had most experience with?
For most of my experiences, I would say I have not used that much of Ceph. I have used Ceph, but not that much. I would say not my personal experiences with that. But only thing, because don't have that much of a latency issue and that much of a sensitive data or that sort. So I have been using the old storage classes myself. But you can use Ceph, Rook. These are all enterprise grade solutions for your databases and for your data. So you can use that if you have sensitive data, you have a latency issues and all of those things. Okay, so now I have scaled it up to 3 replicas. So now you can see that the pod, its logs didn't start from 1, rather it started from 15, because this pod had already, the first pod, this which is running from 118 seconds, had already logged something on the file. And now if you see that the data is totally inconsistent, 17, 18, 18, 20, 20, 21, 22, 23 are missing. So data is inconsistent because all of these three are sharing the same volume and are basically trying to change the data of that volume. So all of these are sharing the same data. So you can see that 70 is above it, 68 is after it. So because we have a random sleep function, so this this pod might have slept for 3 seconds and this might have slept for 2 seconds, but when it wrote back to the file, so the data got inconsistent. So for that matter, we don't use PVCs or persistence for deployments when we have a sensitive data. So as you can see that the data is out of order. The data consistency is totally not in place when we are using one PVC with 3 replicas of a deployment. So let me delete it. Same is the case with Daemonsets. I will just apply the Daemonsets and I will try to move forward with Stateful Sets. Okay, it is stuck. Okay, so again, persistence in Daemonsets, it will be totally same. They all will be sharing the same PVC. The logs will be totally out of order again in case of Daemonsets. It is also never used. This is just to show you the differences between the three in terms of persistence. Now
Okay,
coming to
one more question from Michael. Thank you, Michael. What if I have a volume or drive with data that's needed for the application? How can you coordinate the app startup and make sure that the data from the volume is available for it?
sorry, didn't get you.
Oh, it's okay. So what if I have a volume or drive with data that's needed for the application? And how can you coordinate the app start and make sure and be sure that the data from the volume is available for it?
Okay. Okay. So basically, you mean to say that the volume is provisioning the time that it takes to provision that things. So for that, basically, we have probes in Kubernetes. You can have a probe, readiness probe and liveness probe. So what readiness probe will do is it will not mark your pod as ready until and unless you specify your command. So you can create a command that it should check whether the volume has been created yet or not, or you can have init container for it as well. So init container, what it will do is you can have that thing until and unless that, if you can check in the init container, once that condition passes, only then the main container should start running. So you have two options for that. Okay, so coming to stateful sets, the main thing that is used for data on Kubernetes, the main controller. Stateful sets is the main controller that is used for managing the stateful applications. You declare the PVC template inside the stateful manifest, and it guarantees the ordering and uniqueness of pods by having incremental naming convention. The replica pods are not interchangeable. They have a unique numbering. For example, 0, 1, 2. They have an incremental numbering whenever you have multiple replicas of a stateful set. Each replica has its own state. They will not be sharing the state of each other. They are not interchangeable. They are separate entities. They are separate, you would say, have their separate state. So they are useful for databases. How they are useful for database, I will be coming back to it in a moment. So this is how is persistence in stateful sets is done. This is a stateful set, one replica. It created a pod counter dash 0. In deployment, as I said, that the naming of the pods was totally random. It was not.
Sorry, Ali, we got another question. You're getting so many questions. This is incredible. Just curious, what happens if we use two replica sets in YAML of the deployment and use EBS block storage for PV?
One will connect to it, the other one will fail, saying that the EBS cannot connect to more than one instance. So okay. One will be able to connect to it because EBS can only be connected to one instance. So one will be able to connect to it, but the other will be failing, saying that we cannot connect to the EBS more than one instances.
Perfect. Thank you.
So this is a pod. It created a PVC counter -0, and it all looks good. But what if I scale it up? If I scale it to 3 replicas? So what it will do is it will not create 3 replicas at once as deployment did. What deployment did was it scaled it up all at once, because as I said that they are interchangeable. In stateful sets, it will create a new pod counter -1. It will have its own PVC. It will then, once the counter 1 is totally up, it's ready, it will create the other pod counter -2, which will have its own PVC. So now counter 0 and counter 2 cannot be interchangeable, because it has its own PVC, it has its own data, and this one has its own data. You cannot say that the counter 0 can be replaced with counter 2, because they both have their own data. So if we use deployment for databases of stateful applications, data consistency can be compromised, which we just saw. We were just writing to a file and reading that file. So deployment were not able to consist the data consistency part. High availability cannot be achieved. If the PVC is deleted from this image, if I delete the PVC, then all of the data is gone for each of the replica. So data high availability cannot be achieved. Stateful sets, one drawback of stateful set is that they don't have replica sets. So you have no rollback option. You have to manually roll it back to the previous version. And I will just show you the example for the stateful set. Okay, one thing that I missed, let me first delete it. Okay, for stateful set, that when you delete a stateful set, the PVC does not get deleted. That is a benefit for stateful sets, that even if you delete the basically stateful set, the PVC does not get deleted. So I'm making sure that the PVCs are deleted before applying the stateful set. So there are no stateful sets, no PVCs. Okay, one's just started. I'm not sure why, because I just created that. Maybe that's why. Okay, it is in terminating state. Once it's terminated, I will have to manually delete this. Okay, so yeah, it is now deleted. So now I am applying a stateful set. So now we will see we have 3 replicas of my stateful set. We can see the first PVC got created, counter -0, and the first pod got created. It is once it gets in the running state, then the next pod will be created. This is up. Okay, stateful set. Okay, there are only one replica. Sorry, the stateful set has only one replica. I was seeing the deployment. Now if I scale it up, so let's see the magic. I have scaled it up. It is creating a new pod counter -1. A new PVC is being created counter -1, and a new pod counter -2 is also being created, and the PVC is also there. So each PVC has its own pod, and each pod has its own PVC. Let me just apply the deployment again, so you can see the difference and can confirm that I am telling the right thing from the PVC. So over here you can see that there are 3 pods connected to the same PVC: counter -7 GRC, counter -7 R9, counter -7 V2. So the same PVC is connected with the 3 pods but in stateful sets, each of the pod has its own PVC. So how is it beneficial, and how is it beneficial for databases? Let's move on to that. So what happens is, whenever you deploy a database in a Kubernetes cluster, you want it to be highly available. So what happens is you create a cluster for your databases. For example, if we are deploying Postgres on our Kubernetes clusters, what we want is we want a cluster of Postgres basically database. So one would be the primary replica, other 2 will be the secondary replicas, which will just be syncing the data from the first primary one. So these 2 are secondary replicas, and this is the primary replica. This is read write, and these are only writing or reading the data from Postgres 0 and basically saving the state. All the basically activity that will be performed on this pod only. These are only read-only replicas, the secondary replicas. What if this goes down, the pod goes down or the PVC goes down? So what will happen is one of the two secondary, they will become the primary one. And as stateful set is a controller, it will provision a new pod with the same name. So as it was before, for deployments, another issue is that we don't know the exact name. For stateful sets, the name will be same, and now it will become the secondary replica. Now Postgres 1 is the primary replica, and it became the secondary replica, which will again start copying the data from the primary replica. So that is a benefit of using stateful set. Each have its own state, each is maintaining its own state. You can have a highly available database in your basically cluster, and that's how it works. And why do you need stateful set for database? Again, databases form clusters. You can never have replicas of your database. Always you will be having clusters. One will be the primary one, other would be the secondary one. Each individual pod should have a unique identity because you can communicate with each other. As the cluster, it communicates with each other. The primary one should know the name, or it should be able to predict the other pod names. As we said that the stateful set, it increments the name, counter 0, counter 1, counter 2, counter 3. We all can easily predict what would the name of the next replica would be. And even if the one pod goes down, it will come back with the same name as before. So the networking will be easy. For deployments, the name would obviously be different whenever a new pod will come up. For stateful set, the ordering, the uniqueness, that will remain always over there. And the PVC doesn't delete automatically, even if pods or stateful sets delete. Just the example for it, I will just delete the stateful set. We can see that the PVCs will not get deleted. The pods will get deleted. The pods are in terminating state. The PVCs will not get deleted, even if the stateful set is being deleted. So that's another benefit of stateful sets. So whenever you recreate the stateful set, it will again use that same old basically PVCs.
Wow.
So
as usual, we got more questions because you're making everybody's minds get really busy. So we got another question from Leonard. So a front-end stateless deployment will tap into a back-end stateful DB database pods?
yeah, basically front ends, they are tend to be stateless application. They do not have any sort of a state in them. They're just serving the front user. So you can have deployments for it, and you can have multiple replicas. Each replica will be same, whether the call goes to first replica or the second replica. But the databases, they would obviously be using stateful sets, or any application that has state involved in it, you would be using stateful sets for it.
Okay. And then one other, well, a couple other questions. Well, one thing to follow up with that. The database stateful sets are served by PVCs in terms of hard disk storage.
Yeah, basically the PVCs, that obviously you need to choose whichever storage class or whichever storage volume you want to choose. You can use EBS, you can use EFS, you can use any, even in your node, you want to have, for example, I have 3 node clusters. So what I could do is I can have the storage of these node as well as my PVC. But obviously that is totally up to you, whichever you want to choose.
Wow, I can say this is meetup number 49. I'm sorry that originally in your slides it said 46 because it was 46 when we had scheduled it, but we had some meetups in between. Well, I say that just because one of the things that I really liked about this, having seen so many meetups, is starting with the building blocks, and then we finish with the things that are a little bit more complex. I think you can tell that you have experience as a trainer explaining these things, also handling the questions super, super well. Few times have we had so many questions in a meetup, so it's really nice to see those things getting answered for folks. Ali, what are the resources that you go to learn about data on Kubernetes?
First of all, basically Kubernetes own documentation. That's quite good. Kubernetes own Kubernetes.io documentation. They are quite good. You can go to that. But other than that, obviously you need community for it. The DoK community is also quite helpful. Other than that, you have a Kubernetes Slack in itself. Whenever I get stuck on something related to Kubernetes, first thing I do, I ask a question over there, and then I do my research, because meanwhile, some member from the community can be able to answer me or help me. Similarly, for the data specific questions, the data on Kubernetes community is quite a good initiative. and you can do that. But for basic searching or for basic knowledge gathering, Kubernetes own documentation is enough, I would say.
Great point. We got another question as well from Michael. Do you have a demo with NoSQL and relational databases?
Not at the moment, but obviously I have deployed multiple databases, but that can be made, but obviously not at the moment.
Okay. No worries. Okay, let's see. Or any other resources that might be related to NoSQL and relational databases. Michael, I would also recommend jumping in our Slack. And if you ask the same question there'll be plenty of people that in the database chat that we have going on. They could definitely help you out with that. So feel free to, if you want to continue it there, get in our Slack. As I said, if you're not in our Slack already, get in our Slack. Check us out on Twitter. We're also on LinkedIn, constantly sharing stuff. We have another meetup coming up this week. We have plenty of things going on. This was a very, very informative meetup. And this is another reminder to all the folks that are out there. This is a perfect example of what we're going for as a vendor neutral community. It's very difficult sometimes to say, like, these are the kind of talks that we're looking for. And then sometimes we still see, corporate corporate slide decks, and it's not what we're looking for. So I really, really think, and this is a comment we just got from Carlos saying, a really interesting presentation. Thank you very much. Thank you, Carlos, for your comment. But Ali, you can see the feedback's really, really good. Now, my question is, when can we have you back? Because this is exactly the style that we want. So that once we get, as we said, that it's not so daunting, it's not so overwhelming, that we can unpack these concepts and see how they're working. And so, as usual, before folks start taking off, Ali, you met Angel in the very beginning, and what Angel was doing while you were explaining everything so wonderfully was creating this graphic recording. So you can check out some of the visual summary of the different things that we were talking about. It's always nice to see, how we started and kind of how we finished. Once again, like I said, I think Ali did an excellent job of just explaining the basic concepts of containers, pods, showing what, the questions that Kubernetes was answering in the early days. So I think it's a very nice visual summary of all the stuff that we're able to touch on there. As I said to everybody previously, you can definitely check us out on Slack. You can check us out on LinkedIn, on Twitter. Happy to answer questions in Slack as well. Still getting great feedback from our guests who are here today. Ali, your blog, we'll link that later in, like I said, in Twitter and LinkedIn. You're quite active in different spheres, but as you saw, folks, he's very capable of answering questions very quickly. So feel free to reach out in Slack if you have anything else. Ali, any other closing remarks you'd like to make before we finish up?
No, basically you have summed it up quite well. Just only thing is that what I believe is Kubernetes is the future. Kubernetes is the future of hosting applications. So jump on it, research it, and don't just try to deploy applications. Know the basics out of it. My main purpose of this talk was that you should know the basics out of it, because I myself was deploying Helm charts. My task was being done whenever I was deploying applications using a Helm chart, but I didn't know what was the main difference between these resources. Similarly, other resources on Kubernetes as well. Kubernetes is quite complex, but try to grasp the basics of different things. So that's my ending point.
I think it's a great way to finish. We started with a little bit of Urdu. How do we say goodbye in Urdu? I know shukriya is thank you, but how do we say goodbye?
Khuda Hafiz.
Ooh, well, you'll have to write that down for me so I can practice. Khuda Hafiz, you said?
Yeah.
Okay. All right. I still got to work on that. But anyway, good to finish with different languages. Much love to everybody in Pakistan. Hope that someday we can do a live in-person meetup in Pakistan. I would love to go there to hang out with you in Islamabad. So anyway, Ali, thank you again. And we'll continue the conversation in Slack. Thanks, everybody.